All right, let's jump right in. Welcome to this explainer on one of the most awe-inspiring natural wonders on Earth. Today, we're exploring a geographical feature that doesn't just dominate a landscape, but actually shapes the climate, culture, and history of an entire continent. We're talking about the Himalayas. But as you're going to see today, this isn't just some static pile of rocks. We are looking at a dynamic, living giant. To really get a feel for this giant, you kind of have to start with the name itself. The word Himalaya comes straight from ancient Sanskrit. It combines two words, Hima, which means snow, and Alaya, which means abode or dwelling. Put them together, and you've got the abode of snow. Honestly, it's the absolute perfect description for a place that seems to quite literally scrape the sky. Okay, let's dive into this incredible view taken from the very edge of space. When India's first astronaut, Rakesh Sharma, looked down at his country, he actually remarked that it looked better than the whole world. And seeing this stunning, sweeping curve of snow and ice acting as a massive natural barrier, you can absolutely see why. The staggering scale of this mountain range is almost impossible to wrap your head around until you zoom out this far. To put that colossal scale into perspective, just think about the number 8,000. Many of the peaks in the Himalayas tower at over 8,000 meters in height. In the climbing world, these absolute behemoths are famously known as the 8,000ers. And this monumental range isn't just contained to one spot. It's a massive geographical wall that stretches across 6 different countries: India, Nepal, Bhutan, China, Pakistan, and Afghanistan. But hey, the Himalayas are so much more than just a playground for mountaineers. They have a direct daily impact on human life as the literal water tower of Asia. Why? Well, in the summer, the snow and ice sitting on those towering peaks starts to melt. That meltwater cascades down and feeds some of the world's most critical river systems like the Ganga, the Indus, and the Brahmaputra. Through drinking water, farming, and industry, this massive water tower sustains the lives of literally hundreds of millions of people downstream. And beyond just physical survival, the abode of snow offers deep spiritual sustenance. These mountains hold immense cultural significance and are considered deeply sacred across multiple belief systems. If you travel through the high passes, you're going to stumble upon ancient temples and hidden monasteries built right into sheer cliff faces. For centuries, spiritual seekers and monks from all over the globe have journeyed to these high, freezing altitudes for one simple reason: to pray and meditate in the absolute quiet of the peaks. Flashback, a dramatic geological collision. To understand how this massive water tower even exists, we have to rewind the clock. The origin story here is epic, it's violent, and it completely redrew the map of our world. A really, really long time ago, the landmass we now call India was actually connected to a massive supercontinent called Gondwana, hanging out right next door to Africa. But then it broke away, and it started to migrate north across the ocean at what is, geologically speaking, an unbelievably rapid pace. You can see the milestones right here: 71 million years ago, 55 million, 38 million, racing northward on a collision course with Asia. And this brilliantly illustrates exactly what that timeline actually looked like. You can physically see the shape of the Indian landmass barreling up through the Indian Ocean. Around 50 million years ago, this unstoppable tectonic force finally reached the Eurasian plate. And when it hit, it didn't just casually bump into it and stop. No, it violently slammed into Eurasia, driving unimaginable amounts of earth and rock straight upward. To really visualize what happened, think of a heavy rug or carpet lying flat on your living room floor. If you forcefully shove one end of that rug toward the wall, what happens? The material in the middle has absolutely nowhere to go, right? So it crumples, it folds, and it pushes up into ridges. That is precisely what happened to the Earth's crust when India rammed into Eurasia. The land crumpled and was forced up into the sky. And we know this isn't just a theory because the evidence is recorded right there in the stone. Look at these folded layers of Himalayan rock. You see those dramatic, sweeping, wave-like patterns in the mountainside? That is solid bedrock that was literally bent and folded like it was Play-Doh. The immense, mind-boggling pressure of 2 continents colliding did that. It is just a stunning visual record of the Earth's raw power. Descending the 3 mountain zones. Having seen how they were violently pushed into the sky, let's take a guided trip down through 3 distinct geographical zones: the Himadri, the Himachal, and the Shivalak Hills. We're starting at the very top, in the Himadri, also known as the Greater Himalayas. This is the highest, most unforgiving part of the entire range. It's where you'll find those 8,000ers we talked about earlier, including iconic peaks like Mount Everest and Kanchenjunga. Because of the sheer altitude, this zone is locked in snow all year round. As you'd expect, survival here is incredibly tough, so human settlements are extremely sparse. Moving just south from that extreme freeze, we step down into the Himachal, or the lower Himalayas. Here, the vibe changes completely. The climate becomes way more moderate, which allows for some incredibly rich biodiversity. It's also far more welcoming for people to actually live in. In fact, this zone is famous for its gorgeous hill stations, places like Darjeeling and Shimla, that totally thrive in the cool, comfortable mountain air. Finally, we reach the outermost and lowest tier, the Shivalik Hills. You can basically think of this area as the foothills. We're talking rolling hills and really dense forests. It acts as this vital, gentle transition zone between the towering giants above and the massive, flat Gangetic plains below. Because of the heavy forest cover, the Shivalik Range is absolutely teeming with wildlife, completely wrapping up our descent from the frozen peaks down to the bustling, living forests. A living, growing wonder. So we've covered their ancient formation and their modern structure. But here is the truly mind-blowing reality of the Himalayas. This massive continental collision, it isn't just ancient history. It is an active process happening right now. The giant is still moving. Now, what's really fascinating about this number right here is what it represents. 5, specifically 5 centimeters. That is the exact distance that the Indian landmass is still pushing into Asia every single year. The collision that kicked off 50 million years ago, it never actually stopped. The Earth's tectonic plates are locked in this continuous, incredibly slow-motion wrestling match, inching 5 centimeters further north annually. To help you really grasp that speed, let's put it into everyday terms. 5 centimeters a year is a huge amount of tectonic movement, but on a human scale, it's virtually invisible. For context, the average human hair grows about 15 centimeters a year, which means entire continents are crashing into each other at a speed 3 times slower than the hair growing on your head. How wild is that? But that slow, relentless push has a direct, measurable impact on the mountains themselves. Because India is still plowing into Asia, our wrinkled carpet is still being crumpled up. The result? The Himalayas are actually growing taller by about 5 millimeters, or half a centimeter, every single year. So the highest mountains on Earth are quite literally reaching further into the sky as we speak. So the crucial point here is how this tiny bit of math adds up over deep geological time. 5 millimeters a year might seem like nothing, but over a single millennium, just 1,000 years, that growth adds up to 5 massive meters. The landscape is fundamentally lifting itself up millennium after millennium, which leaves us with this final, staggering thought. If this living giant grows 5 meters every 1,000 years, what is the abode of snow going to look like a million years from now? Just how high can the wrinkles of the Earth actually go? It's a pretty incredible testament to the raw, enduring power of our planet. Thanks for joining me for this explainer today, and keep wondering about the incredible world around us.